Okay, so I'm Menges. Should I look at you or?
It's okay.
Okay. So I'm Menges. I'm the director of the Institute for Computational Design. I studied first here in Germany, and then I actually finished my studies at the in London, where I also taught for the subsequent 9 years in the Emerging Technologies and Design program as a studio master. And then I moved here to become the director of the Institute for Computational Design. And since 2009, I'm also a visiting professor at the Graduate School of Design at Harvard University. So the idea or the research area of ICD is really looking at two fields. One is investigating generative computational design processes for architecture, how we can use new algorithmic approaches to design in order to sort of broaden our scope of what design could be and how we can actually utilize new technologies in architecture. And the second research area that we investigate is computational fabrication and robotic manufacturing in architecture, where we investigate particularly at the moment robotic prefabrication, the kind of production of complex building parts and elements that are then assembled on site. And we have what is one special area of expertise that we investigate is how we can actually synthesize these two fields of research. So we think of the computational materialization not as something that is isolated from the kind of generative process of design, but as something that really exists in a feedback loop, so that design informs fabrication, but fabrication also informs design. And we have developed various technologies to allow us to reach that level of integration. One area that we research a lot is natural processes of materialization, because in natural morphogenesis you have exactly this sort of a full integration of form, material, and structure, and even environment. So in natural processes and systems it's impossible to disentangle what leads to a particular form and how that actually is physically established. So for us that's a very interesting precedent, and we do a lot of what here in Germany is called biomimetic research. We look at nature as a kind of alternative source for principles that we can actually abstract them and use in technology. So in our design build projects that usually take the form of these research pavilions, we try to explore that in a kind of limited time frame. So we work in a team with 5 to 6 research associates, PhD students, and 15 to 20 master level students to develop within 1 year a kind of, or let's say start with a kind of investigation of a biological system, which we do in collaboration with the biologists from the University of Tübingen. Then at the same time concurrently investigate new manufacturing possibilities, how we can synthesize these and how we can sort of realize them and use them as a starting point for design for material systems, structures, and in the end these kind of temporary microarchitectures that really give us new insights on what is possible today beyond existing and established sort of structured typologies, spatial situations that we know. So we treat them really as kind of explorative, physically explorative undertakings.
Just one thing I found very interesting, or it's actually very amazing, is you are using different material every year for the pavilion. Is there any reason for that, or you just keep exploring, experimenting?
Yeah. So we are not an institute that is specialized in one particular material.
Mm-hmm.
We assume, are an institute that is specialized in how you integrate the material world into your computational design processes.
Right.
So that is something that is initially not materially specific. Obviously, once you actually start really doing that, every mode of integration is highly materially specific. Material specific, and we talk about material, we refer to that as the materiality, the actual material characteristics and properties, but also the processes of materialization, which is usually fabrication, assembly, construction. All these things have their very particular logics, and they become kind of driver for the design process. So I think our design build exercises are a very important aspect of our sort of educational program here. So we have a dedicated master's level program, which is a Master of Science in integrative technologies and architectural design research, which is actually open to architects, people coming from engineering science, and also people that come from natural science. So it's a truly multidisciplinary undertaking. And for us, in this 2-year program, the first year is sort of one of the critical components of the curriculum. And the first year really all revolves around the design, conceptualization, planning, execution of one of these research pavilions. And for us, that's a fantastic vehicle to actually make our students that all come from different backgrounds, from architecture, structural engineering, system engineering, biology, to make them actually work together, to show them that the most interesting things happen and overlap between these disciplines, that they don't need to leave their core disciplinary knowledge to contribute to these design projects, and in the end also have the kind of reward and sort of the proof that it works out in the kind of physicality of an architecture. So I would say that the design build is an absolutely critical component of our educational program. It's not the only component, but it's the component that is actually really of key importance for the first year, because it sort of allows people to actually venture into this culture of multidisciplinary work and see how they can actually contribute in a team to this kind of level of innovation. I think both the kind of architect and educator, design build is an absolutely important component of architecture education. It's definitely not the only component. So I think you cannot structure an entire architecture study around design build, but I think going through that experience once in your studies is a crucial experience, because it allows you to experience that you can not only design on the level of, let's say, what we usually call a concept design phase, but that you actually can design throughout the entire process. So you can actually also design manufacturing processes, you can design structural performances, you can actually design all kinds of aspects, and I think design build projects make you acutely aware of that and actually allow you to develop a kind of sensitivity towards these possibilities as an architect that you don't usually have if you only retreat to the conceptual design phase behind a computer that produces documentation, sort of construction documentation you can hand someone else. So I think that's one aspect, that's a general aspect, and I think a lot of the very successful architecture programs in the 20th century were revolving around design build, so it's not at all a kind of new phenomenon. It's something that I think has a long-standing history. I think why design build experience revival in architecture schools is simply because the possibilities of our new technologies are so wide, and they really challenge our conception how you design things, that without making it becomes almost impossible to really take full advantage of these new technologies in design. So I think going through this full loop, that you actually understand how materialization relates to the processes of design, how you can actually establish your feedback, really sort of is a crucial experience for the next generation.